Hey math kids, today we're going to talk about surface area, and we're in chapter 6, section B, and we will start with example number 2. So just a warning to start off, my drawing skills are pretty bad, so good luck. I would just look in the book to get these, but just in case you don't have the book, I will draw them the best I can. Okay, so we have a pyramid, and it says that the height, which they're marking as this, it's like the perpendicular height from right there. So the height is 10.8 centimeters, and so it just wants us to find the surface area. And so in other words, it wants us to find all of the triangular pieces. I guess I should draw this too. So there's 4 triangular pieces around the outside and then a rectangular piece at the base. And so if we're doing this, we want to use the Pythagorean Theorem. So we're basically going to take our goal, let's see, how can I explain this? So we're going to take a right triangle out of this, and so the height of that is 10.8, and this is going to be only half. So essentially we're taking this triangle like that, and what that's going to do is it's going to help us find the height of this triangle right here. So the distance from here to here is half of this, which is 6.6, and then our height is still the same. Okay. So using Pythagorean Theorem, whoops, that's not it. So we're using a squared plus b squared equals c squared. So it's going to be 10.8 squared plus 6.6 squared equals c squared. And if we solve for c, we'll square root both sides. Plug all of this into a calculator. Now be careful, this square root does not cancel these squared. Doesn't cancel this, doesn't cancel this. That's a common mistake. Just type it into a calculator exactly how you see it here. So square root, parenthesis, 10.8 squared plus 6.6 squared. Do that, and then you should get 12.66 centimeters. Okay? Now, that's going to tell us the hypotenuse of this, and which is this right here, or the height of that side, however you want to think of that. Now, if you look in your book, on the answer section of this, they draw a diagram that looks roughly like this. Oh, this is kind of a bad picture, but oh well. They point out a few factors with this. So they point out that these are all the same. And then they point out that these are all the same. So we have a square base, and we know that that is, I'll get a new color. That's 13.2. We get that from here. And then we know that the height, so like from here to here, is the h that we found, the 12.66. Okay. So we can create an equation where the area of the base is just going to be 13.2 squared. And then we're going to add it to the rest of what's going on. So we have 4 triangles, And the area of those triangles is going to be 1/2 base times height. So 1/2 times the base, which is going to be 13.2, and then times the height, which is 12.66. Okay, we plug this all into a calculator and we get 508 centimeters squared. Okay, hopefully that cleared up some of the work on there. Sometimes they do work and they don't show the steps in between, and it gets a little confusing. Okay, now on to example 3. It says find to 1 decimal place the outer surface area of, and then we have 3 3D objects. So the first one is a cylinder. Okay, so the radius of the cylinder is 6 centimeters, and the height is 15 centimeters. So it says that it's hollow top and hollow bottom. So hollow top, hollow bottom. And so what that means is we only have to find the curved surface area. And so it's essentially, it's just going to be 2 pi RH. And that's it. So the way we figure that out is we need to essentially think of it like a rectangle. And this is just the circumference of that circle. So circumference is 2 pi r. And if we just plug in a 6, the circumference is 2 pi 6, or 12 pi. And so this is just the circumference of the circle, because we just kind of lay it out like a rectangle. And the height is just our height. And so we multiply by the height, which is 15. So we say 12 pi times 15. And if we plug that into a calculator, we get the area, just the outer part, surface area, to be 565.5 centimeters squared. Okay, part B, we have a sphere with radius equal to 8 centimeters. So the area of a sphere is 4 pi r squared. So we just say 4 times pi times 8 squared. And if we plug all that into a calculator, we get 804.2 centimeters squared. Okay, the last one on this part. We have a radius of 5, and then this side, if we go along here, is 12 centimeters. So we have two things going on. We have the area of the circle. So the area of the circle is going to be pi r squared. And then we have the area of the cone, like the outer part of the cone, and that is pi r s, where s is this side right here. Okay, so after that we just plug in some numbers. So this is going to be pi times 5 squared, or 25 pi. And then this is going to be pi times 5 times 12, or 60 pi. So if we add those together, 60 pi plus 25 pi, and then plug that into a calculator, we get 267.0 centimeters squared. So 267 centimeters squared. Okay, now we're going to move on to example 4. It says the length of a hollow pipe is 3 times its radius. Okay, so the length equals 3 times r. And it says write an expression for its outer surface area in terms of its radius. So once again, this is like the hollow cylinder problem. And it would be 2 pi RH. And that, when we use the values we have, would be 2 pi. And then we need, so length, this is the same as like height, right? So 2 pi r, and then times 3r for the h. So I'm still using this r, but then I'm changing this h to a 3r. And so that's going to be 2 times 3, it's going to be 6. And then r times r is r squared. And then we have a pi in there, so just write it 6 pi r squared. And that would be meters squared. Now part B says if the outer surface area is 301.6 meters squared, find the radius of the pipe. Okay, so it's saying if this expression equals this, what is the radius? So essentially just set it equal and solve for r. So we're going to divide by 6 pi. And then, so we have 301.6 over 6 pi equals r squared. Then we square root both sides. And if we plug that into a calculator, it's approximately 4.00. And so we would say the radius of the pipe is 4 meters. Okay, if you need additional help, please come to Math Lab and calculator.